Hey guys, welcome to Speed Day 11. This lesson is basically a review, so we're just taking what we already know and applying it to new and more interesting word problems, and that's pretty much what we're going to be doing for the rest of this week until our test. Let's get into it. You guys have the speed triangle and formulas at the top there. You can go ahead and rewrite those. You should know by now whether you're correct or not, so I'm not going to go over those again. But let's go over the first word problem. It says, a marble rolled 3,500 centimeters in 70 seconds. Find its average speed in centimeters per second. Now, I've already got my distance speed time chart over there on the left, and I want you guys to do the same. Fill in for the variables that we already know, the distance and the time. And in this problem, we're trying to find for speed. So we'll use our speed formula. Speed equals distance divided by time. We'll fill in our variables. Our distance is 3,500 centimeters and our time is 70 seconds. And you guys could cross-cancel those zeros there, so you would end up with 350 divided by 7. Now, I'm not going to do the division over on the sign today. I don't have, my pen is not working well, so I'm just going to use the PowerPoint. But let's run through the mental math on this. If we have 350 divided by 7, so I've crossed off these two zeros right here. We could divide 35 by 7 really easily, right? We get 5. Well, this time we're dividing 35 tens by 7, and so instead of 5, we're going to get 5 tens, or 50. So our speed is going to be 50 centimeters per second. All right, let's do the next one. You know what? Go ahead and do this and then come back and check your work, because this is pretty easy. So I've got my distance speed time chart over there on the left. We know our distance and our time, but our distance and our speed, we're trying to solve for time. So we'll use our time formula, distance over speed. We'll substitute in 720 meters divided by 8 meters per second. Again, this is another really easy problem to do. We've got 72 tens divided by 8 ones. So if I divide 72 by 8, I'm going to get 9. In this case, it's 9 tens, so 90. So my answer is 90 seconds. All right, next one. Make sure you write down your distance, speed, and time chart on the left. A car traveled 360 miles from town A to town B. If it left town A at 9 a.m., it left town A at 9 a.m. At what time would it reach town B if its average speed was 90 miles per hour? Now we're going to solve for time here, but that's going to give us the amount of time it drove. It won't give us what time it arrived. So then we're going to have to go back and figure that out. So time is distance over speed, 360 divided by 90. Let's cross off those zeros, cross-cancel that, and we're left with 36 divided by 9, which is 4 hours. Okay, that's not our answer, is it? Because the question is, at what time would it reach town B if its average speed was 90 miles per hour? So we need to add 4 hours onto 9 a.m. Now, if we add 3 hours to 9 a.m., we get to 12, don't we? We get to 12 noon. And then we need to add that extra hour on. Well, what happens after 12, right? The numbers start over. So 9 a.m. plus 4 hours is going to equal 1 p.m. So that would be the correct answer. Okay, Lauren took 3.5 hours to travel from town X and town Y at an average speed of 60 kilometers per hour. How long would it take her if she drove 10 kilometers per hour faster? So this is a multi-step problem. I bet you can do it on your own, so maybe you should just go ahead and try. Stop the video, try, and then come back and see if you're right. Okay, let's run through this. So I've got my chart over here. I've got distance 1. I don't know it yet. I don't know how far apart the towns are. But I've got a speed 1 of 60 kilometers per hour. Get that from right here. And we read that it took her 3.5 hours to get from X to Y. So obviously we can find the distance really easily, right? And since the towns are going to be the same distance apart, distance 1 will be the same as distance 2. So let's see what that is. Distance equals speed times time. So I'm going to plug in 60 times 3.5. And my distance in this case is 210 kilometers. Now if you are working this out and you made a mistake there, Don't forget that when you're multiplying decimals, you need to line up the digits. So you would line up vertically your 60 and your 3.5, and then you're going to keep track of the fact that you have one decimal place in a factor, and so you would add, you're going to end up with like 2,100, and so you would add that decimal place back in, cut off the trailing zero, and get that 210. Okay, so it's 210 kilometers for both distance 1 and distance 2. Now we're set to find our new time. So it's going to equal distance over speed. I forgot to point this out when we started here, guys, but notice that my speed 2, that I have 70 kilometers per hour. Up here in my word problem, it said, how long would it take her if she drove 10 kilometers per hour faster? Okay, so the faster is in reference back to this 60 kilometers per hour. So that means we're just adding 10 kilometers per hour to the speed. So that becomes our speed 2. So we'll substitute in our variables. We have 210 kilometers divided by 70 kilometers per hour. And again, we can probably do this in our heads. Let's cross off the zeros. And then we have 21 divided by 7. And our time is going to equal 3 hours. So she would cut off a half an hour. Okay, let's take a look at this one. This one is a fun one. It says Cole took 24 minutes to skip around a 400-meter track 3 times. Find his average speed in meters per minute. So our distance here is not 400 meters. He goes around it 3 times. So it's really 400 times 3. So let's set this up for time, speed. Speed is going to equal distance over time. And our distance, if we multiply 400 times 3, 4 times 3 is 12. We're multiplying hundreds, so we want to add 2 zeros. And we're going to get 1,200 meters divided by 24 minutes. And that is going to equal 50 meters per minute. Alright, Kevin left the town A at 7:45 a.m. and arrived at town B at 10:45 a.m. His average speed was 55 kilometers per hour. Find the distance between town A and town B. So we're given times that he left and arrived, and we need to find the difference to find our amount of time. So if he arrived at 10:45 and left at 7:45, the difference is going to be 3 hours. So I already have that marked up on my chart up there. Make sure that you're keeping up with taking the notes on your notes and writing everything that you see on your on the screen there. And we're going to solve for distance. So speed times time. I bet you guys already have this solved by the time we're here. But it's going to be 55 kilometers per hour times 3 hours. And our distance is going to equal 165 kilometers. Okay, you guys should go ahead and pause the video and give this one a try, and then come back and check your work. Okay, Mr. Huey drove to Colorado Springs 240 miles away at an average speed of 80 miles per hour. If he left at 8:10 a.m., what time did he arrive in Colorado Springs? So, our distance is 240 miles. He's traveling 80 miles per hour. We're going to solve for time, but that's going to give us an amount of time that we're going to need to then add back on to 8:10 a.m. So let's set up our time formula. Distance divided by speed. And it's 240 miles divided by 80 miles per hour. Oh, look at this. Another easy one to solve in our heads. And our time is going to equal 3 hours. So if we add 3 hours on to 8:10 a.m., it's going to be 11:10 a.m. So there's my answer down there. All right, our next one is a two-parter. I think you can solve this one as well. You should stop the video and solve this and then come back and check your work. Okay, Zach took 4 hours to cycle from Fort Collins to Estes Park. His average speed was 18 kilometers per hour. Find the distance between the two towns. That's part A. So let's do that first. So we'll set up our distance formula, speed times time. And we'll plug in our numbers, 18 kilometers per hour times 4 hours. we'll multiply that out, and we will get 72 kilometers. Okay, now we know our distance. We're going to use that for part B. So now it says if his average speed was increased by 2 kilometers per hour, how much time would he take for the trip? So if he increases his time by 2 kilometers per hour, that means we're going to add 2 to 18, and we come up with 20 kilometers per hour. So now we're all set to solve for time. So we'll set up our time formula, distance divided by speed, 72 divided by 20, and we're going to come up with a decimal. So if we divide that out, our time is going to equal 3.6 hours. All right, folks, that's it for day 11 of speed. Be reviewing the different types of word problems that we've been doing. Your test is in 4 days, or 3 days. Your test is in 3 days. So make sure you brush up on anything that you're still not clear about and ask questions in class.